Today we're at Jake's house in a 14-foot deep hole along the side of the foundation talking about insulation. Joining us is Craig Novak, project manager for the Jake's house. So let's get to it. We're in the basement, and specifically the space outside the basement where we're going to be putting waterproofing and insulation and drainage for the outside of the basement to make sure we never get water inside. But today we're talking about insulation, and specifically the insulation that we're putting underneath the slab and on the walls of the foundation. And we have a lot of different choices on insulations that we can use. But the insulation that goes in this space has a lot of characteristics that need to be specifically defined because of the pressures of the house sitting on the foundation and the insulation, and also the dirt and the rock. So Craig, tell us a little bit about what this insulation is and what specific characteristics this insulation had to have in order for us to be able to use it underneath the slab.
Well, there's several items that we have to be considerate of is lack of water absorption, the ability to not compress when the load of the mat slab and the foundation walls are on it, and resistance to temperature, of course. So we have a certain thermal value, R value to this layer. I think we have 3 inches here, 2.5 inch layers that were combined, taped and bonded.
Okay, so we do. I actually see tape in this holding all these sheets together so we don't have any air leakage between the sheets. This insulation is all EPS, which is expanded polystyrene. Does all EPS have the same required characteristics that allow us to use it under here?
No, we have to specify what type of EPS, so resistance to compression.
Okay.
Type 1 is about a 10-pound. Type 2 is...
That's PSI,
pounds per square inch.
Okay.
Type 2 is 20 pounds, et cetera, et cetera. This is a structural foam, so absolutely made for being put underneath the whole slab.
Okay, and who defined the PSI requirement for that foam insulation?
So we have a geotechnical study that tells us what the Earth's able to carry.
Okay.
And we know where we start, but that would be the level of what we need to compare to. Okay. And we just brought that up as better.
Okay. So really, like the ground underneath this building would give way before this foam would give way.
Yes, indeed.
That's amazing. So now we have this insulation, and did we pour our concrete directly on top of the foam, or was there something in between the foam and the concrete that made sure we didn't get water into the structure?
So this layer is similar to what is underneath the entire slab. It's a blindside waterproofing. Okay. And that was all taped and sealed to create basically a bathtub. So anything that's outside the foundation will not be able to penetrate this.
So no matter what, when the waterproofing is taken all the way up to the top, no matter what happened to the water outside here, there's no nook and cranny or hole that would allow the water to get into that space.
Correct. So some basements of yore, they used to just build the basement and they'd use a very simple waterproofing. So if you had cracks happen at a later date, those cracks are avenues for vapor or water transmission.
Okay. So we also know that we have options of other types of insulations to use here. So we know that XPS, which is an extruded polystyrene, has a similar function but uses a different refrigerant, and so it's actually got a much higher global warming potential, meaning it's worse for the environment. Why didn't we use that here? Or was that specifically why we didn't use it
That's
here?
Absolutely why we don't use it. This is recyclable. I don't believe we'll ever dig down to retrieve this material, and nor with a basement of this kind, this house will last a very long time. Okay. But there is that capability to reuse EPS.
Okay. Then what about things like fiberglass or stone wool or things like that?
No, because they're very compressive. So there's nothing that could resist the pressures down this far in the earth.
Okay. So really this was our best solution that also had the lowest environmental impact and the highest R value.
Yes.
Okay. Now we're standing on a bunch of rock right here, and we know that there's something new coming into the United States that's essentially a recycled glass that they heat up and then they put a bunch of air bubbles into it. It's almost like pumice, like volcanic rock.
Manufactured lava.
Right. So I know we looked at that for this project because we could have actually not even used this foam. We could have used that recycled rock or that recycled glass for not only the rock underneath, which is specifically here to allow water to drain away from the foundation. So it's called a capillary break. But we could have actually used it to replace the insulation underneath it because that pumice, that man-made pumice, has an R value.
I think it's R1 per inch.
Yeah, something like that.
Somewhere
So
1.5.
why didn't we use that here?
Because we're about our carbon footprint. So we use a very special concrete mix to lower our carbon impact. And to get that material that's currently manufactured in the United States on the East Coast out to here, we kind of hit a balance point between EPS or that. But we're not driving trucks all the way across the nation to bring the EPS here.
Okay. So the cost of the EPS was actually a little bit more than the cost of this man-made pumice. But the man-made pumice would have had to have been shipped from essentially the East Coast.
Yeah, so overall they were almost identical in cost, including the trucking. And it doesn't make sense to bring something with that much diesel across the country.
Okay. And so really what we're trying to do here, and we understand that it's incredibly important to maintain the insulation of this passive house around the entire passive house. And that means underneath the foundation, on the walls of the foundation. So we're gonna, after the waterproofing is up on this wall, are we gonna use the same insulation that we did here on the walls?
We'll bring in a lesser grade, same material, the sides will be a full 2-inch.
Okay.
And it's a type 2, which is a 20 pound per square inch resistance.
Okay, so it's a little bit less strong because the house isn't sitting on it, but we're backfilling this with gravel afterwards, which is gonna push against that foam. So we wanna have it so that it doesn't compress, because we know that when insulation compresses, you actually lose R value, because now it's not 2 inches or 1.5 inches thick, it's 1/2 inch thick or 1 inch thick.
Right. So we have a drain barrier in front of that. It'll take a lot of the impact of the rock.
Okay.
And the rock will be a loose fill, slowly raised up and kind of self-compacting.
Okay.
Until a certain level where then we physically start compacting the material.
Okay.
To reach our 90% compaction for the surface areas.
Okay. And this wasn't actually required for California basement. None of this was required.
No, on our Title 24 report, we only had to have insulation on the interior.
But we're still going to have insulation on the interior.
Yes, we're doing a combination and a very large amount of insulation inside as well.
Okay, so really what we're trying to do is make sure that the house retains all the heat, or in the respect of the summertime, stays cool all year round by reducing its bleeding of energy into the environment because of insulation or lack of insulation.
The tonnage studies for this house in our passive house report were at 1.5 tons, which is what you might heat and cool a 2-bedroom apartment for. And this is a 7,000 square foot house. Okay.
So really, building a better way is about building energy efficient houses. And in this respect, a very, very energy efficient house. So a project that is about 1/6 to 1/10 the size uses the same amount of energy as this house will when it's done. If you're interested in following our projects, learning more about building science, or just learning more about green building, hit subscribe as we show you how to build a better way.